The engineering medal is given to professional engineers who have contributed substantially to advancing the engineering profession in any area of specialization. The recipients' achievements are significantly above the high standards of the profession. This year, the engineering medal is being awarded in the following categories: engineering excellence in industry, management, entrepreneurship, and research and development. The Engineering Medal for Research and Development recognizes professional engineers who have developed novel applications, advanced engineering knowledge, or made a discovery in engineering or the natural sciences. The first recipient of the Engineering Medal for Research and Development is Dr. Farrokh Janabi-Sharifi.
My name is Farrokh Janabi-Sharifi, and I am Professor of Mechatronics Engineering and the Director of Robotics, Mechatronics and Automation Lab at Toronto Metropolitan University. I did my PhD degree in Electrical Engineering at the University of Waterloo, and later I moved to McGill University as a NSERC postdoctoral fellow and instructor at Center for Intelligent Machines and Department of Electrical Engineering at University. And in '97 I moved to Ryerson University, and where I'm currently serving as a founding director and associate chair of mechatronics engineering. My research focuses vision-based, image-based learning and control of robots, plus Continuum Robotic Systems. As a result of my research, we have published 290 journal and conference publications, 9 books. We have been collaborating with 40 domestic and international industries. Research from my lab led to 14 technology transfers, 4 patented technologies, and 2 spin-off companies. In my background, you can see samples of prototypes of Continuum robots. This one is 2 Continuum robots holding an object which is flexible, and they are supposed to manipulate it. And the other one is supportive arms will support the main arm. And the reason is that by moving the supportive arm along the main arm, we can play with its rigidity. One of the beauties of the Continuum robots is we can scale them up or down. The good example of scale of Continuum system is the elephant trunk. Scale down is the catheters that go inside the cardiac chambers or brain for intervention. Continuum robots, their main purpose is for sort of laparoscopic surgery. In the sense, they go through the veins. The same day the patient is released, the small cut, the catheter goes inside your brain, cardiac, your liver, kidney, and do the operation without damage. As a result, these systems are being adapted for surgery. Like, we thought that if we make them cooperate, we can increase their payload and also increase their workspace. A good example is like cardiac surgery or for mitral valve replacement through catheters. Sometimes the surgeon drops the catheter inside the chamber, and then they have to do open heart surgery. But with cooperative Continuum Robotic Systems, one catheter can come from one channel, the catheter can come from other place, and together they can go and pick up the valve, bring it back to the location, and then install it. In industry, Continuum robots could be applied in many places. Jet turbines, thousands of parts. If you want to look at the inside, or you have to open layers of blades, layers of the systems. The Continuum robots, you can go inside to do repair or even imaging of the part. Cooperative example, one could hold the camera, the other one could do the operations. Another development in this field for aerial manipulation systems. Aerial robotics drones are becoming more popular. The problem with them is they require the drones to approach and do work on the environment. Example, repair of the power lines under the bridges, As a result, we thought that nobody has integrated soft continuum robots to the drones. So we introduced the field. The challenge is, of course, the control. That's one of my active research areas in my lab right now. Training highly qualified students is one of my main motivations. And since 2005, I started developing a mechatronics program for our students. And that program now takes more than 100 students per year. When I heard that my work service have been recognized by the society and professional engineers, I became very excited and very honored.
In recognition of his pioneering contributions to robotics and mechatronics, which have transformed the capabilities of intelligent systems operating in complex, real-world environments, Dr. Farrokh Janabi-Sharifi is a worthy recipient of the Engineering Medal for Research and Development.